Hello students, let's take up the topic from chemistry in this video. So let's start and see that what important and interesting topic we are going to take up today. The topic which we'll be taking in this video is the states of matter, and this video is part 1 of states of matter chapter. Now let me give you a short intro to this video. As you can see in this figure you can see lot of things in it, right? You can see the buildings, you can see the vehicles, you can see water, you can see plants. There are a lot of things that you can make out in this picture. So all the things which we can see in this picture occupy space and they also possess mass. So anything that occupies space and has mass is regarded as matter. And matter exists in different states. So in this chapter we are going to study about that what exactly the matter is. We'll focus on the examples also, and we'll see that what are the states in which the matter can exist, and can we interconvert those states or not, and if yes we can interconvert, then what are the factors that actually help in interconverting the states, and lots more about the states of matter. So let's start with this interesting chapter. So the first thing which we'll be doing is matter. What is matter? See, matter is anything that occupies space and has mass. As I told you that if you have anything and it is occupying a certain space and possess mass also, that is regarded as matter. Let's take a few examples. As you can see in this picture, this is a brick. And this is a cylinder that you all use, right? And this you can see is milk. So even we can focus on the glass also in this picture. So in this pictures you can see that these things, when kept, they are occupying certain space also, and they have some mass also. So all of them is actually, you can say that they are the examples of matter. Now earlier the matter was classified into 5 elements. Like in earlier time there were few scientists and they just tried to classify the matter. They classified the matter into 5 elements, and they were air, fire, earth, water and sky. And these elements were regarded as 5 elements, also called as Panch Tattva in Hindi. So these elements actually refer to, you can say that they are the components of matter. They are regarded as the components of matter. Now let's see that what is the present classification of matter, or how we can classify the matter. Let's see that what are the factors that can make the matter classified. So we have two sort of classification. One is chemical classification and other is physical classification. So let's see that what is the difference between the two. So the physical classification is that which is done on the basis of physical properties. Now the question must be arising in your mind that what are physical properties? See, those properties which can be felt, seen, right? They are called as physical properties. For example, if I give you a copper, let's say a piece of copper. So on looking at it, you can make out that it possesses the red color. As you know that copper is reddish brown, so you can say that it is red in color, and by looking at it you'll say that yes, it is quite hard. That means it is not soft, it is quite hard. Because it is hard, so obviously its density is also going to be on a higher side. So these things which you can just make out by just looking at it are called as physical properties. Now the second classification is chemical classification. Chemical classification is done on the basis of chemical composition of matter. Now what is chemical composition? Chemical composition means that what actually the matter is made up of. What are the constituents of matter? So depending upon those constituents, its nature is going to be different. Like if we take different forms, their chemical composition is going to be different. Therefore, they will possess different chemical properties. They will have different chemical nature. Like some will react with some substance or some will not react with certain substance. So this is what is chemical classification. So I think you got it. That we can classify the matter on the basis of physical classification, in which we focus just on the physical properties of the matter. And second is the chemical classification, in which we focus on that what are the constituents of that particular matter. So now let us do few activities to learn more about matter. So the first activity is that matter is made up of particles. Now in this activity we are going to show that how we can prove that matter is made up of particles. That what is the evidence for it. So let's take up an activity. So in this activity we'll take a beaker, we'll take a common salt, we'll take a spoon or a glass rod. We'll take a beaker and we will fill the beaker with 3/4 water mark, right? So what we'll do is, in the second step, we'll add common salt to it. We are adding salt to it. So I think you got it. We took a beaker, we filled it with 3/4 level of water in it, and we put a spoon of common salt, that is table salt, that is NaCl, to it. Now what we see is that when we dissolve salt in it, so initially the salt gets settled down, as you can see in the figure, that initially the salt gets settled at the bottom, and then we stir it. As you can see in the third picture, we are using a stirrer and we are just trying to stir it. So when we stir it, what happens? The salt starts disappearing. Salt starts disappearing, and a stage comes when it totally disappears, that you cannot see the salt settle at the bottom. So it completely disappears. So at this point, this is confirmed that it is not one continuous state of matter. Instead, it is formed of small particles. So it proves that it consists of not only one state, it consists of small particles. Because when you are stirring, these particles are actually moving around and they are occupying the space between the water molecules. So on stirring, the salt particles get dissolved in water, but still the level of water remains same. Like you took this much water, so when you added salt, then also the level of water remains the same, and when you stir it, even that time the water level remains. This shows that salt particles occupied the hollow space which was present between the particles of water. Now those spaces are occupied by the salt particles. So that is the reason that water level remained same. So I think you got it, that this is the activity which can be used in order to prove that the matter consists of small particles, and also you can use this activity for proving this, that these particles are in a state of motion. That is the reason when you stir them, then they preoccupied the space between the water particles. And third, you can prove from this activity that there was a hollow space between the particles of water. So that means the particles are not so closely bounded. There are certain spaces that is occupied by the another matter, that is the salt particles. Because they were small, so they occupied those hollow spaces. So I'll just write it down. So first we can prove this, that the matter is made up of particles. We can prove that matter is made up of particles. Second, what we can prove is that particles are always in state of motion. Their motion is not ceased. They are in a state of motion. That is the reason when you stir them, they actually moved and occupied the spaces between the water molecules. Third is that there are spaces which can be present between the molecules of matter. There can be a spaces between molecules of matter, like you saw in the water molecules. And also one more thing, that particles are too small. The particles can be too small in size. That is the reason here the salt particles were too small, that they occupied the hollow spaces between the particles of water. So I think you got to know much about matter now. Now let's do another activity to show that these particles are always in state of motion. So this activity is conducted in order to prove that the particles of matter are always in state of motion. So to do this activity, what we did, we took agarbatti, matchstick and a stand to hold. You know that this is a stand, this is an agarbatti, right? And we also need a matchstick to light up the agarbatti. You must have seen that we use agarbatti at our house, right? So when we light it up, what happens that its fragrance actually gets scattered in our house. Its fragrance actually gets scattered in our house. So what happens, you can easily make out, like if you're sitting in room and somebody is lighting the agarbatti outside, then also you can just smell its fragrance. The reason being, when you light this agarbatti, then the fumes from there, they have the tendency to move from the region where they are present to the region where they are not present, and in this way they are just spreading out, and the fragrance can be actually distributed in overall in the house. What we are going to do in this, take one stick out of packet, hold it on stand, and which is placed at the corner of the room. Now what you will see that you can smell its fragrance even though if you are far. So the whole room starts smelling very good. Now what is the reason behind it? The reason is the particles of matter are not stationary. They are moving and they are continuously moving, and when they drift through air, we can smell the perfume. That means the fragrance is spread all over the house, and the reason being because the particles of matter, they don't remain stationary here. The fumes actually spread and mixes in the air and gets spreaded evenly. That is the reason your whole room starts smelling very good. So when the stick is lighted, the heat energy makes the particles of perfume move rapidly. As you know that agarbatti has a sort of perfume in it. So when you light it up, then there is a heat which is produced and which makes the particles move rapidly and spread evenly in the whole house. So they easily drift through air and spread smells. So this proves that the particles of matter are not stationary, they are continuously moving. Now, do you know that what is the reason or what is the basic phenomena behind this movement? That is diffusion. See, anything, or you can say any substance, always move from the place where it is present in the higher concentration to a place where its concentration is lower, right? So if you have anything that has the tendency to diffuse, that is the movement of any substance from the region of its higher concentration to the region of its lower concentration. Or we can also call it as intermixing of two different substances. Like in this, you know that these are the fumes which are liberated by agarbatti, right? So their concentration is more near the tip of agarbatti. But if somebody is sitting here, so the fume particles are not that much present here, right? Or you can say they are almost nil at this place. So what happens, these fume particles starts moving to the place where their concentration is lower. So their movement is from the region of their higher concentration to the region where their concentration is low. And how they are moving? They are moving because they are getting the energy to move. They are getting the energy to move. Like in this, when you are lightening up, so when you are lighting up, then the heat is produced. That heat is taken up by the particles for the movement. Now, we have an activity to prove that particles of matter also attract each other. There is an attractive force that exists between particles of matter. So for this, what we took iron nail, piece of wood and a rubber band. We have this thing, the piece of wood, we have the iron nails, and we do have the rubber band. Now what we do is we try to break them. So what we will notice that rubber band is easy to break. This is easy to break. And then what is easier to do? Breaking of wood is much easier as comparison to the breaking of iron nail. So now what is the reason that we can easily break this, and then second comes this wood, and the third we have is the iron nail. So what is the reason behind? Let's see. The reason is that the force of attraction that exists between the particles of matter. The force of attraction that exists between particles of matter. If the force of attraction is higher, then we cannot break it. And if the force of attraction is lesser, then we can easily break it. For example, in this case, what we get to see is that in iron, the force of attraction is maximum because the particles are so closely packed that there is strong force of attraction and we cannot break them easily. So that is the reason, that is the force of attraction indicates that which substance can be easily broken or which substance cannot be easily broken. Now we are done with the activities, and now at this point you know much about the matter. You know that matter is made up of particles. You know that particles of matter are always in state of motion, and you also know that they also attract each other. So now, taking those points into consideration, we are formulating a theory of molecular structure of matter. Theory of molecular structure of matter. It is also called as kinetic molecular theory of matter. Kinetic molecular theory of matter. The other name for theory of molecular structure of matter. Now we know that matter is made up of small particles. Matter is made up of small particles, and those small particles are called as molecules. The molecules are not stationary. They are always in state of continuous motion. So we can say that because they are not stationary and they are always moving, that means they possess kinetic energy. Because we know that every substance which can move possess kinetic energy. So here also the molecules are not stationary, they are randomly moving. So that is the reason they possess kinetic energy. And this kinetic energy increases with increase in temperature. So if you increase the temperature, then kinetic energy also increases, right? And if you decrease the temperature, then also the kinetic energy decreases. So that means kinetic energy is directly proportional to the temperature. Kinetic energy is directly proportional to the temperature. And next, what we have seen is that kinetic energy is maximum in gases. Kinetic energy is maximum in gases and least in solids. The reason being, in solids the particles are very tightly packed, right? So they cannot move, so they don't possess that much kinetic energy. But in gases, the particles are far apart, right? So the reason being because they have low force of attraction, so that means they are far apart, and likewise they have a good amount of kinetic energy, and so the particles are far apart, therefore they can move easily and they possess higher kinetic energy in comparison to solids. Now the molecules, like we know that the molecules are there, but in certain substances the molecules are very tightly packed, and in certain substances they are at certain gap, and in gases they are far apart. So that means the molecules possess intermolecular spaces. Inter means within, molecular, that means between molecules there is a space. So there are spaces that exist between molecules, and they are called as intermolecular spaces. So these spaces are very less in solids, but in gases they are on a higher side. So we can say that intermolecular spaces are maximum in gases and least in solids. Now there is an attraction between molecules of matter. There is a certain attraction between molecules of matter that make them stay at the position where they are, or you can say that make them a part of a single substance. So the force that exists between particles is called as intermolecular force. So inter means between, molecular means molecules, force is an attraction. So there is a force, attractive force, that holds the particles together, and that is intermolecular force. But as the spaces between the particles increase, the force decreases. Obviously, if you are closer to somebody, then your force of attraction will be higher as in comparison if you are far from that person. So that means intermolecular force is more when the particles are closer, and if the particles possess more intermolecular space, then intermolecular force is comparatively lesser. So we can say that intermolecular space decrease with increase in intermolecular spaces. Now the important topic which we are taking up is that the phenomena that supports the kinetic theory of matter. That what are the phenomena that actually support the kinetic and theory of matter. As we have done that the matter consists of molecules, we have already done that molecules possess kinetic energy, and we have already done this also, that kinetic energy is directly proportional to temperature. We also did that between the molecules there are intermolecular forces and they do possess spaces, and if the space increase then intermolecular force decrease or vice versa. So these were the actual postulates. If we sum up these postulates, these are the actually postulates. So these are the postulates of kinetic theory of matter. So what are the phenomena that supports this theory? The phenomena are diffusion, Brownian movement and osmosis. Now let's study. So in this video we will be taking diffusion and Brownian movement, as osmosis is not a part of your syllabus, but still we'll define it when we'll do the questions. So if we talk about diffusion, as I already told you, we took an example of agarbatti. I told you that the particles of matter, they have the tendency to move from the region where they are present in higher concentration to a region where their concentration is comparatively low. Right, I told you that. So this movement is called as diffusion. So whenever the substance moves from the region of higher concentration to the region of lower concentration, that phenomena is called as diffusion. And due to diffusion only, the movement of particles are possible in case of matter, and that is the reason they possess kinetic energy in them. So diffusion is an important phenomena, and we have seen that diffusion is shown maximum in gases. The reason being because their intermolecular force is comparatively less and their intermolecular space is comparatively more. So that is the reason they diffuse at higher rate. But it is least in solids. The reason being, in solids the particles are tightly packed, due to which the intermolecular force is on the higher side and there are very few or almost nil intermolecular space. So that is the reason they cannot diffuse easily. Now the factors that affect diffusion. What are the factors which affect the diffusion of a substance, any substance? First is the state of matter. We know that the state can be solid, liquid or gas. So we have seen that if the substance is a gas, then the diffusion rate will be much faster because its intermolecular spaces is going to be high and intermolecular force is going to be less. So its diffusion tendency will be on a higher side. Second is intermolecular force. We know that intermolecular force is an attractive force that holds the particles together in a particular substance or a matter. So if intermolecular force is high, then obviously the diffusion is going to be less. That means the particles will have less tendency to diffuse. So we can say that intermolecular force and diffusion tendency is inversely proportional to each other. Third, we have temperature. We know that if we supply temperature to any substance, that means we are providing heat to a substance. Heat means we are providing kinetic energy to a substance. So if kinetic energy will increase, then the diffusion tendency will definitely increase. So we can say that on increasing the temperature, diffusion tendency also increases. So that means they are directly proportional. And on decreasing the temperature, we are extracting heat. That means kinetic energy is ceasing. So that means the diffusion tendency will decrease. So we can say that it will increase with increase in the temperature and diffusion will decrease with decrease in the temperature. Next we have pressure. Right. Now we have seen that if we apply pressure on any substance, like if I take an example, if I take some sample and I am applying, let's say, pressure with the help of piston on them. So when I am applying pressure, obviously these particles will come closer to each other. They will move closer to each other. And as a result, their intermolecular force will increase and space will decrease. And now if the force will increase and the space will decrease, obviously the diffusion tendency is going to decrease. The diffusion tendency is going to decrease. Next topic we have is the Brownian movement. So what is Brownian movement? We have seen that there is a zigzag motion of particles of matter. We have seen that the particles of matter are like that. They have the tendency to move, but how they move? They move by pushing each other, like they are in state of continuous motion. So when they are moving, it like say it is hitting this particle. When it is hitting this particle, it gets hit in this direction, then it hits this particle. So likewise, they are forming a zigzag sort of movement in the substance. So it is shown maximum in gases because intermolecular space is on higher side in case of gases, moderate in liquids and least in solids. The reason being because in solids intermolecular forces are quite high and space is almost nil because the particles are very tightly packed. So this Brownian movement is clearly seen in gases, moderately in liquids and least in solids. For example, it is seen that when the pollen grains are suspended in liquid like water or if they are suspended in gas like air. So if pollen grains are there, they show a movement like this that is called as a zigzag movement, which is termed as Brownian movement. Now let us do few question and answers. So the first question is, what is matter? We have done that anything that occupies space, I'll just write it down, anything that occupies space and has mass, that is called as matter. For example, we have chair, we have table, we have pen and lots more, because everything which surrounds us, most of them, they occupy space and they possess mass also. So everything that is surrounding us is an example of matter. What are the three states of matter? These states which we'll be taking in the next video in detail. Otherwise, you know that the states of matter are solids, we have liquids and we do have gases. So these are the three states of matter. Next question we have is, differentiate between osmosis and diffusion. So what is the difference between the two? So let's make out the difference. See, diffusion and osmosis. Diffusion is the movement of substance from higher concentration to lower concentration. Diffusion is the movement of substance from the region of higher concentration to lower concentration, right? And if we talk about osmosis, osmosis is also a movement but not of any substance. In this case, it can be a movement of solid, it can be liquid or it can be gas. But in case of osmosis, it is the movement of solvent, that is the liquid part. Movement of solvent from the higher concentration to lower concentration, but there is a membrane that separates or that sees that only the solvent molecules pass. So we can say that it is a movement of solvent from higher concentration to lower concentration across a semi-permeable membrane. Semi-permeable membrane is a membrane which allows movement of only selected substance. Like in this case, it is allowing the movement only of the solvent molecules. So I think you got it. In diffusion, the solid, liquid, gas, anything can diffuse. But in case of osmosis, only the solvent molecules move. They also move from higher concentration to lower concentration, but there is no any specific selective membrane present. But in this case, to show osmosis, we have to use a semi-permeable membrane, that is a selected membrane which allows the selected movement through it. Thank you. With this we finish part 1. Thank you for watching it, and for learning experience you can visit www.wasserats.com.